Welcome to the lecture on control of welding distortion. So, in the last lecture we discussed about the distortions which take place during the welding process, and you have different types of welding distortion, like you have longitudinal and transverse shrinkage, you have angular distortion, you have buckling and twisting and all that. Now, the thing is that whenever the distortion is taking place in a welded specimen, that means that the specimen becomes out of shape, then it does not work satisfactorily for the intended service, and in that case it may affect the productivity of the process, and you try to minimize the distortion. That is why, and in fact you would like to have no distortion. So, but that is not possible maybe many a times. So, we need to look those methods by which you can control these welding distortions. So, for that you may have to select proper operating parameters, proper working variables, so that the distortion is minimum. So, as we discussed that since the distortion leads to unacceptable deviation, distortion means being out of shape. So, the deviation which is there from the standard dimension, so that may lead to many a times a lot of negative results, and that may lead to many kind of losses. So, we need to see that how this distortion is to be minimized. Now, many a times the residual stresses and distortion to a large extent behave in a contrary way. This means that many a times when you try to see that the residual stresses should be made smaller or it should be removed. So, many a times it also happens that you do that method by which the distortion becomes more, or you try to remove the distortion maybe by so suppose you have a distortion of a specimen which is twisted or so, and if you try to use the press or you use certain load and try to remove the distortion, so this distortion may be minimum, but then the residual stress maybe during that process may shoot up. So, many a times they behave also in a very contrary way. But then ideally we would like to have both the values to be on the lower side. We also want to have residual stress also on the lower side and distortion as well, because both are in most of the cases they are not desirable that way, especially to I mean if its value is higher. So, residual stresses in certain sense may be beneficial, but in most of the cases they are harmful. Similarly, distortion anyway is not desirable, because once you have distortion, you would like to minimize it, or you would like not to have distortion at all. So, we feel that we must have the minimum amount of the residual stress as well as distortion. So, annealing is there a process which basically will be reducing the residual stresses, but then if you do not practice the annealing in a proper way, if you have not a proper and controlled annealing process, that may also lead to warpage or distortion, because in the annealing you are heating to a certain temperature, then holding at that temperature, then further in cooling. So, if you are not heating at a proper rate, you are heating very fast or cooling fast. Holding time is also not proper or so. In that case also, although you may get somewhat the removal of stresses, but that may lead to warpage. So, you will have to control these variables or the processes, so that you have controlled value of residual stress or the value of residual stress as well as the distortion within a limit, so that you can take use of the component. Now, there are many methods of controlling these distortion in the welds, and the common methods which are implied are least root gap. So, root gap is when you must be conversant with the welding terminology. So, you must have minimum of the root gap. Then proper tack welding. Tack welding is something which you must have the idea that when you have the thin portions to be welded, we use the tack welding. This is basically to do to control the distortion, because we have seen that especially in the rotational distortion areas, where we see that you are welding along a line, and as you reach towards the end, then when you are welding like this, if suppose this is the weld line and this is the longitudinal direction. So, the thing is that either this may go like this, or this may go like this. So, basically what we do normally is the tacking is done so that you are fixing these points by using the tack welds. So, that way once you put the tack weld at different locations, and then you are doing the welding process. So, that is a way to control the distortion of that type. So, that we will discuss. Narrow groove section is basically we must have a groove section which should be narrowest to the possible, because that will minimize the amount of weld metal in that, and we discussed that as the amount of weld metal is more and more, it's more likely to give you the larger value of distortion. So, the narrow groove section is another important parameter. Similarly, direction of welding, in what direction you are welding, what is the restraint, where is the restraint, so what way you are welding, that is also important, in what direction you should weld, so that you have the minimum distortion of generated. Then least metal deposited, again this is supporting the same principle, that if you have least metal which will be supporting the joint, then you will have least distortion. Larger will be the metal, larger is will be the likely distortion. So, least metal deposition is another parameter which is important. Then you have welding sequence. Welding sequence means how you have to proceed in the welding. What way, if suppose you have a particular type of welding structure, then in that case suppose you have transverse welds or you have longitudinal welds. So, if you have plate type of weld structure, cylindrical type of structure which is to be welded, in that case what way you should proceed, how the transverse welds, whether should be welded first or longitudinal welds should be welded first. There are certain defined steps which should be followed. Similarly, a backstep welding process is also there, where the welding should be in the backstep manner. So, backstep welding tells you that how you have to proceed the welding. In the longitudinal direction you have to go, but then you have to go in a backstep manner. Many a times you have a counter setup. So, many a times what happens that the welded structure bows, or it has a sagging type of tendency in one direction. So, you are trying to have a counter setup. So, suppose it bows in this direction. So, you put the specimen itself in the opposite direction, so that even if there is a bowing or so in certain direction, then it will be flat one even after the welding. So, this way you have the different types of methods which are there for controlling that distortion in the welds. So, we will discuss one by one all these methods. So, the first method is having the least root gap. So, we would like to have the root gap as small as possible, but sufficient for the good penetration. So, excessive gaps must be avoided, and for that it is also advised that the included angle should be not more than 60 degree. So, that way you will have the minimum amount of metal. So, once you include the you increase the included angle, then you will have that will be adversely affecting the distortions and all that, because there will be more of the weld metal, and accordingly the design does not support that. So, that may lead to the larger amount of distortion. Now, it is also suggested that when you have a heavy section, in those cases the double V type of preparation should be preferred. So, like that you have certain principles which should be followed, and so that the distortion, so that will try to minimize the distortion. Then second is the tack welding. So, tack welding is used normally for the accurate fabrication in case of seam welding. When you are welding along a seam and for larger lengths, then in those cases normally you use this tack welding, and it should be sufficiently long to reliably transmit the shrinkage forces. So, it should be, when you are putting the tacks, you must have the tack of certain length, and normally this length is a function of the thickness of the sheet which you are welding, or thickness of the plate, and this tack weld length is normally kept as about 2 to 3 times the thickness of the plate, so that it can reliably transmit these shrinkage forces. Then hardening and cracking of the tack weld may occur if of inappropriate volume. So, if there is inappropriate volume of the tack weld metal, then in that case there may be hardening of the tack weld, because that has to transmit the heat. So, it will transmit the heat, it will cool fast. So, in that way there will be hardening, and then there may be crack developed. So, especially when you have you are using the small volume of tack weld. So, and that too in the very large weld volume. So, if you have the plates of larger thickness, and if you are putting the small amount of tack weld metal, so in that case the heat dissipation will be very fast. So, in that case the heat dissipation rate being faster, the chances will be there that it will be extremely hard, and there may be cracks. So, what we do normally is that we normally preheat the that material before when you are tacking. So, then in that case preheat the plates, so that when we tack, the heat extraction rate will be not that fast, and it will avoid any kind of hardness or cracking during that process. Then as we discussed that there may be crack formation, and as well as there may be other even welding defects. So, for that we can do the preheating, or when we are doing the tack welding, then at that time you must also take care of removing the slags. So, it is just like a welding process. So, you must remove that, otherwise when you are doing the further welding process, in that case if the slag surface is there prior to that, so that may lead to another slag inclusions or other type of welding defects. So, you have to be careful for having the appropriate tack welding, so that the and if you are choosing appropriate tack welding by using the appropriate process, in that case the distortion is likely to be smaller. Next is the narrow groove section. So, groove section should be as narrow as practically feasible to permit smallest possible heat input and filler material in conjunction with highest possible heat concentration. So, that is what the requirement is there. you feel that it should be as narrow as possible, and you give the heat input smallest possible heat input, and also the concentration of that heat source should be highest one. So, that will basically reduce the chances of distortion. If your heat source is having poor concentration, if it has large spread or so, in those cases the chances of distortion will be more. So, we think of having narrowest to groove section, so that the minimum of the distortion is taking place. We also try to see that the fusion zone and the plastic deformation zones, they are smallest as possible. So, in that case the chances of distortion will be minimum or so. Then we normally try to see that we should have such kind of groove selection where you have smallest possible cross section is there. So, in that case the heat extraction rate will certainly be depending upon the area. So, if you have smallest possible cross section, then in that case the chances of very fast cooling will not be there. So, if you have some grooves which have very larger cross section of the same for the same volume, in those cases the chances of heat extraction will be fast, because heat extraction is depending upon the cross section. So, you would like to prefer such kind of grooves which have the minimum kind of areas, like you prefer the square type of grooves. Then many a times you prefer U type of groove as compared to V type of groove. So, they give the more satisfactory results. And if you have symmetrical weld grooves, then they produce less shrinkage, and although they increase the residual stresses, but then the shrinkage is normally small, and there are certain practices like you use the double V groove instead of single V or Y groove, and then similarly you prefer the double sided fillet joint instead of single fillet joint to reduce the distortion. So, if you go for double sided fillet joint, you try to prefer that as compared to a single sided. So, that will single sided is likely to give you more distortion. So, these are the precautions which we must follow when we are going to have the proper selection of the groove section. Now, coming to the direction of welding. So, in that in what direction the welding should be carried out depending upon the welded structure. So, it should be we have to keep the precaution that it should be away from the point of restraint and towards the point of maximum freedom. So, that should be seen. Otherwise, if you are moving towards the point of restraint, then certainly there will be larger chances of the distortion taking place, because stresses will be more, there will be restraint reaction stresses which are generated, they will be larger and larger, and in that case the chances of distortion will be larger. So, you try to follow the welding in the direction in which you have maximum degree of freedom. So, that way, that is the better practice of controlling the distortion. Then you have least weld metal deposited. So, basically we know that as the quantity of weld metal deposit will be more and more, the amount of contraction will be more. So, that will lead to more of the distortion. So, you should see that you are not putting any excess metal. So, that is why no excess metal should be deposited, and you should see that when you are making the weld deposit, the proper weld drawings should be made, and there should not be any increase in the weld section, so that there is increase in the weld metal deposited. So, that way if you have minimum amount of weld metal to be deposited, which will suffice to the condition, or which will be sufficient for the structure to be considerably stronger, then in that case that is better. Then comes the welding sequence. Now, welding sequence is that if you use the proper welding sequence, both sign and magnitude of the deformation can be controlled. So, what is there, that how you are doing the welding, you have transverse seams, you have longitudinal seams. So, how you are approaching when you are welding certain type of structures. So, when we are welding the job of large surface area consisting of several plates. So, suppose we have a structure which is consisting of many plates. In that case, you have the transverse seams, as well as you may have the transverse seam as well as the longitudinal seam. So, if you have a longitudinal structure, you may have the seam on the transverse direction as well as on the longitudinal direction. So, in that large surface area consisting of several plates, you try to seam in the sense sequence that first of all you try to seam weld the transverse seams, and then in the once all the transverse seams are welded, then you are welding the longitudinal seams. So, that is the welding sequence. So, and how you are welding. So, sequence means 1, 2 or 3, that also is among the transverse also. If you are going, then in that case you are basically telling that 1, 2 and 3. So, it is not that we are also doing, if you have many regions of tack weld. So, you are also going in the same like from 1 to 2 or 3 or so in one direction. So, there also you have to follow certain sequence, so that the distortion is minimized. So, similarly for other structures, in many cases when you have circumferential type of joints, you go for circumferential first longitudinal seams and then the circumferential type of joints. So, especially in the case of cylindrical vessels that we follow, that we in those cases we try to weld first the longitudinal seams, and then in the end we go for welding the transverse seams. So, that is the proper welding sequence which we follow in the case of this proper welding sequence. Then the next point is backstep welding sequence. So, this backstep welding sequence is it's a very important measure. It's a very good way for counteracting wedge shaped opening and closing of weld grooves. So, as we discussed that many a times when you are welding, then we have rotational distortion cases where the edges either they move towards each other or they are moving apart from each other. So, for such occurrences, to avoid those type of processes or happenings, we normally use these backstep welding sequence. So, in that case what is there, that normally the groove opening, if the groove opening is suppressed by the prior tack welding or by rigid welding restraint, then there may be roof shaped type of arcing of weld joint occurs. So, what we do is we first put the tack welds, that also we feel that what should be the spacing between the tack welds, that depends upon the welding speeds. So, if you have low welding speed, then there has to be low spacing between the tack welds, and then the first weld layer where we put that is subsequently deposited in the backstep sequence. So, what is there, that once you have suppose you are welding two plates like this. So, what is there, that if suppose you have to go like this, now you have put the tack welds like this and this also, these are the tack welds. Now, tack welds, we have discussed that tack welds what should be the length of the tack weld, and that way you have different regions, and it depends upon the thickness of the plate which you are welding. So, you have so we do the welding in this sequence. So, we go for back step like this, from here to here, or from here to here, then here to here, like this. So, then next here, and then here and here, and then finally here and here, like that. So, we go in that sequence. So, it is known as a back step welding sequence. So, welding direction is same, but we are moving in this fashion. So, this is known as the back step welding sequence. So, what we do is we tack weld from one to opposite end. We are moving to one end to the opposite end, and we are basically first we do the ends, and then we are find the remaining layers also are basically on that also it is applied, alternating the directions. So, we do from here to here, then we go from here, then we are going from here to here or so. So, this way the tack welds are applied. So, basically this is one of the very important process parameter which is used for diminishing the transverse as well as longitudinal shrinkage of the weld joint as a whole, and widely used in the case of manufacturing of large structures like ships or tanks or so. Then other you have other methods also for controlling, like many a times you are using the counter or opposing setup. So, that is that in this case what we do is sometimes certain members like the vertical members, you give somewhat slight reverse bend. So, they bend in certain direction, like in a T joint. If you take the example of a T joint, so there will be warpage due to the contraction of the weld. So, what we do is we give somewhat reverse bend so that the distortion is reduced. So, once we have reverse bend, then it will further bend in the opposite direction. So, ultimately you will get a flat type of structure. So, this is about the other methods for controlling the distortion. Now, many a times we also put the backing strip in case of butt welds. So, that is another way for reducing the distortion. Now, we will discuss about something about the distortion control in thin plates and sheets. So, when we do the thin plates and sheets welding, the thing is that basically the because of the intense heat which is applied, because of that distortion takes place. So, what we do is normally we also use the copper chill blocks. So, we use these copper chill blocks under the joints, so that maximum of the heat is extracted by these copper chill blocks. So, the chances of warpage or buckling because of the intense heat content, that will be reduced. And we can also use the water cooled jig also many a times, so that because copper tubes are brazed to the copper holding chamber, and then water is circulated through these tubes, and most of the heat is taken away by this water. So, this way, I mean, the purpose is that when you have thin sheet, it is very difficult for it to carry that much heat in such much of time, and so because of the heat it may buckle or distort. So, we place some conducting material so that allows the extraction of heat fastly, and the distortion will be a minimum. We can also have the fixing in many cases. So, by proper fixing in the frame, so that you have the more rigidity to the structure. So this way you can avoid this bending and angular distortion. So that is another way of controlling the distortion. There are other also ways of controlling the distortion, like you may have the mechanical method of using presses, then you may have the use of oxyacetylene methods like torches or so. So this way you have the different methods by which you can control the distortion. You can have different type of burners or oxyacetylene flame or so. So they are also used, but then you have to have the precaution that when you use these thermal methods, you must see that they do not change the property of the material, because they will be acting on the surface of the structure. So that precaution has to be taken. So these are somehow they talk about the different methods of controlling the distortion in the welded structures. Thank you very much.